Thanks for returning that. You were just slightly late, too. Did you have a rough morning? Or just a slow one? Although I'll tell you what, it is nice to wake up with the sun today and not in the darkness. I love one of my favorite days of the entire year is daylight savings time in the fall. In the spring, it's one of my most hated days of the year. I have no idea why I get so ecstatic about 1 extra hour and why I get so unbelievably angry about losing an hour. Like the week we lose an hour, I'm always like, it should be 7. Like I'm always like fixing it in my head and getting mad about it. Anyway. Huh?
I didn't know about daylight saving until last night.
Oh, you just,
Yeah, I didn't.
your phone just changed and you didn't even notice?
And my parents get up super early, so they changed everything for me
You
too.
know, I woke up super early, it was like 5:30.
A lot of those things just automatically change.
Instead of having to fix your clock.
And then everything else my parents did, so.
Oh yeah, my dad, he was, so the clock was off, his phone was wrong, he was like, which one is the right one? He was screaming at me to fix the clock.
I was mad about my car being off this morning. I was like, aren't you an intelligent car? What's going on? It was a 3x6.
I paid so much money, you can't even fix the clock.
All right, there's 6 of us. What should we come up with today?
Well, what is standard deviation?
Sample standard deviation is different from population standard deviation in the fact that it's calculated slightly differently. Sample standard deviation is denoted by the letter S. And sample variance is S squared. Do you remember that the other one was sigma, looked like an O with kind of a tail off of it? Okay, what should we get data on? How about how many neighbors can you see if you walk around your house? If you walk around the house you live in, how many neighbors can you see? Like how many houses can you see? Some of us live in the country, so some of us will be like at 0.
Is it counting houses near your house? Or?
Yeah, well, I mean, like you can visually see them. So like if you were to walk around the outside of your house, how many other houses could you see? I think I'm at 8.
I'm at 9.
It's 12. Mine's 15.
15? Four? Do you guys remember what a sample mean, what the symbol for that is? Nope, that's sample standard deviation. X bar, yep. Do you guys remember what the symbol is for population mean? Was that U with a tail out front? Do you remember what it's called? Mu, like a kitten, yep. All right, so grab a calculator if you don't have one. We're adding these numbers up, and then how do we find out the mean? Exactly. Add them up, divide by how many you have. Let's all do it together. Did you guys get 59 when you added them up?
Yep.
And then let's use 9.8 as our X bar. Okay, now this standard deviation starts the exact same way as population standard deviation, so what should I do first? Guys remember from your homework?
X minus M.
Yep, x minus mu, but in this case it's x minus x bar. So you're gonna take 8 minus 9.8, we're finding all the deviations, remember how far they are off. So I'm gonna split up the work here. Nathan, you're doing this one. Autumn, Michaela, Jessica, Carlos, and I'll do this bottom one. So in case you're confused, I'm taking 4 minus 9.8 right now. And I got negative 5.8, and you should take your value and subtract 9.8 in your calculator. Nathan, what'd you get?
Negative 1.8.
Autumn?
Negative 0.8
Mm-hmm. Michaela?
from 2.2.
Jessica? Carlos? 1.2. Okay. Does it make sense to you guys that half of them are above and half are below? Is that always going to be the case? No, sometimes you got something like all of them will be below and one will be way above. Like if I was finding the average test score of people and everybody was hitting 90s except for one kid who didn't take the test. And then that would be like a super low score, right? It would be affecting the mean. Next thing we're going to do is make them all positive by squaring them just like a population standard deviation. You've got the exact same one again. Remember, it should be positive when you square it. You can either put it in parentheses or just know that when you square it. Michaela, what'd you get?
I got 4.84.
Nathan?
3.24.
Autumn? I'll give you a second. So you take this one, the 0.8, and square it.
Okay, could I just times that by?
0.8, yep. And also the square button is right here, diagonal to the 7 if you ever need it. Jessica, what'd you get? 27.04? Okay, can you say it sadder though? Can you say it sadder next time though? 27.04. Like, we're really gonna hone that skill. Carlos?
1.44.
Autumn?
I think I'm doing this wrong.
What'd you get?
Like, this says error.
Okay. So type in parentheses on top of the 8. The negative is down here below the 3, not the minus sign. That's probably what got you.
The minus.
Negative 0.8 parentheses, square it. 0.64, did you get?
Yep.
Okay. Yes, you don't even have to put the negative in there. You could just know that it's going to be positive. I'm just saying that if she wanted to do it in the future. All right, now what's the next step?
Yeah, in this case, it's supposed to be positive.
Yep, all of these should be positive. What should we do now? Go ahead, say it.
Do we add them all up?
Yep, add them all up. Everybody try this independently so that we can get, because we're just making up this data, so I don't have this already pre-done. Did you get 70.84?
Yep.
Okay. All right, now here is where it is different from population standard deviation. Okay. You know how normally we would divide by 6 here? We actually divide by 1 less. So the only, I'm going to write it down here. The only difference